recursion tutorial, and I'm going to use Python to solve a popular problem. And a recursive solution is one where you can break the original problem down into smaller subproblems that are basically the same format as the original larger problem. So in this, what I'm going to do is solve an n by n matrix. And what I want to do is find the number of paths to the origin from any point on this matrix. So a recursive solution is useful because if I'm at point 1, 1, I can get to the origin, and it's the same. Finding the number of paths to the origin is the same as if I was at point 2, 2, and the same at point 3, 3, and on, as well as any of these outer edge points. So this is a perfect example of how to use recursion to solve a problem, and I'm going to be using Python to do it. So open up your favorite text editor, and the first thing that we're going to do is just create a variable named numpaths. Set that equal to 0. And then let's go ahead and create two starting variables. Okay. Actually, what I'm going to do is, so those are going to be our starting points. So at point 2, 2, so if this is 1, 1, this is 2, 2 here, that'll be our starting point to test our little algorithm. And let's go ahead and create a function. And in this function, what we're going to do is pass in our current right path as well as our left path. Okay. Now, in every recursive solution, you need a base case to figure out when to break out of the function calls. Okay. And that's because when you use a recursive solution, you call the same function over and over again, which means that I will be calling this function within the function itself. All right, so our base case here is going to be if right path is equal to 0, or if left path is equal to 0. Okay, and then what we want to do if we're at the origin from either side of the right path or the left path, I guess it's if we're at the edge, is we are going to return. We're going to return 1 because we found one path to the edge. Otherwise, if we're not at one of the edges, now here's where the recursive part comes in. We're going to call numpaths, except we're going to pass in our current right path minus 1. So we're going to travel 1 block to the right, but pass in our same left path, plus the original right path and left path minus 1. Okay, so that's it. That's the end of our function right there. Let's go ahead and save that. What I'm going to do is run this file really quickly just to make sure everything looks okay. Invalid syntax. Oops, I missed something here. Left path minus 1. There we go. Rerun that. Okay, everything looks good. Now what we want to do is essentially just set up our variables so that we can use the variable we created earlier, do our outer function recursive function call, and our original values are going to be start x and start y. And then what? Let's go ahead and print out the number of paths. All right, run this. Let's clean up our script a little bit. Take away these spaces here. Make it look a little bit prettier. Add a comment. Outer function call. Okay, let's save this. And if we're starting from 2, 2 of our x and y location, the number of paths back to the origin, or 0, 0, should be 6. And if you look at a little grid here and trace it out, so our algorithm is starting down the right path and taking 1 off the right path each time. So if we go this way, that's 1 path, and then there's 2, so on and so forth. It should be 6 total paths. You can trace that out for your sanity if you want. So when we run it, we get 6, and everything looks good. So that's how you use recursion and a recursive algorithm to find the number of paths using Python in an n by n matrix.